Hello, I am Ajwat.
And I am Quen. Good
Good
evening.
evening. Corrosion is a never-ending challenge. Left untreated, it can make an aircraft airworthy in just a few years.
Thanks for watching us on the news. Today we would like to talk about the issue of corrosion fatigue of aircraft structure. On 24 June 2013 in England, there was one accident caused by corrosion damage to the turbine engine during an Airbus A330 running at airport in Manchester. At a speed of 190 km per hour, the right engine caught fire.
The investigation showed that there had been a fracture of one of the turbine blades. The blade failed due to high cyclic fatigue initiated by corrosion pitting.
Before we go further, we would like to explain a little about the common corrosion on the aircraft structures that always occurs. Aero engines and other parts of the aircraft are designed on the principle of very high power to weight ratio, and hence each of the part is expected to ensure the highest performance of a profitable long-term operations of the assets. Corrosive deterioration of the critical surface of aircraft come in the way of ensuring reliable and safe operation performance. If the corrosion is not detected and prevented in time, it can endanger human lives. Some corrosive here is the left side of the crawling. It comes in three parts, and this right here is the pitting corrosions that we see after removing the light surface corrosive that was indicated.
The major contributors to the corrosive deterioration of the aircraft are hostile environmental factors and climatic conditions. Aircraft operating in polluted industrial environment as well as in saline coastal climate conditions are susceptible to severe corrosion of the exposed surface. Water vapor, either alone or in combination with acidic constituents such as salts present in a marine environment or fumes and pollutant particles from industries, can initiate electrochemical reaction on the metallic surface of the aircraft, leading to the corrosive deterioration of surface.
On the aircraft structure, corrosive can appear in various forms. The most common is crevices corrosion occurring where the moisture is entrenched in between two proximate surfaces. Under certain conditions, it can graduate from pitting or exfoliation corrosive. Corrosive failure is usually a material failure related to corrosion. We know that this condition requires immediate preservation and protections. Corrosion failure may require sampling and testing of corrosion products, such as in the case of microbiologically influenced corrosion MIC, where viable cultures can provide the most meaningful results.
Many factors affect the type, speed, cost, and seriousness of metal corrosion. The environment is one of the biggest factors to cause corrosion and determine how serious the damage is once it begins. The more an aircraft is exposed to seawater or salt air, the higher the risk of corrosion on the surface and throughout the different parts of the aircraft. Moisture in the air is perhaps one of the greatest risk factors for corrosion. So if at all possible, store and operate your aircraft in a dry climate as much as you can. Temperature can also play a role in how fast corrosion spreads, but it cannot directly cause corrosion. For example, rising temperatures can speed up electrochemical attacks and increase the damage caused by this form of corrosion, especially if the climate is not only hot, but also moist.
Manufacturing processes can make aircraft more susceptible to corrosion, such as machining, forming, weldings, and any kind of heat treatments can leave scratches within the aircraft parts. Later on, if these parts are put in corrosive environment, the stresses can cause cracking and serious damage. One of the most common factors to cause corrosion on the aircraft is foreign material, such as dust, oil, grease, water, battery, acids, cleaning solutions, and flux residue. All of these can cause corrosion is left on the surface of the aircraft for a long periods of time. To keep these foreign materials off of aircraft, make sure to conduct frequent inspections and thoroughly cleanse every area of the planes, even the hard-to-reach area.
Preventing corrosion is much easier than treating it, and one of the best ways is to base the aircraft in a dry part of the country. After aircraft metal is manufactured, it is immediately protected with corrosion-resistant alloy and coated with various metals, paints, and chemical conversions. It will take continual inspections and preventive maintenance to keep the aircraft metal from corroding and needing to be replaced. Crevice corrosion at joints is minimized by sealing the gaps on the joint surface with a polysulfide sealant. The sealant is used in skin to stringer as well as skin to shear types of joints in the fuselage, areas of skin doublets, cord to skin joints for the wing and wheel structure, etc. In case of severe prone to corrosion, such as electrical bonds and antenna peripheries, fillet seals are used.
As the aircraft structures are built from different metals, they can suffer deterioration of the surface due to metals reacting to the environment. The electrochemical process of corrosion can begin even during the process of manufacturing and temporary storage. Even from the moment the aeroplane is delivered by the seller, it must be truly inspected and preserved as well as protected from the corrosive environment in which it has to operate. These protections needs to be considered right at the design and component material selection stage. By adding certain constituents to the metallic substance, we can enhance the corrosion resistance of the systems. Surface coatings used for the aircraft and the components will also protect the aircraft.
Here we have a chart shows the use of alloys in aerospace and the corrosion resistance of each lead. In the context of new materials, we highlight the development of new alloys and the use of noble metals. The use of titanium is the one that has grown in recent years. Another important consideration is that despite we are moving forward, the use of lighter alloys and high performance corrosion resistance of these materials has remained constant or even decreased. Thus, it is necessary to use strategies such as the use of coatings to prevent the rapid degradation of portion of the aircraft. Most corrosion failures are not unique in nature. For any given failure, it is likely that a similar problem has been encountered and solved previously. With proper inspections and preventive maintenance, you can stifle the risk of aircraft corrosion. Thanks for tuning in. This has been the news. I am Ajwat.
And I am Quen.
Stay safe and have a good day ahead.